Greetings to all the viewers. I am Prajakta Dalwai and today we'll be looking at my project Veritas RAG. Well, we all have experienced this at least once in our lifetime. That is, getting irrelevant answer or long hallucinated answer completely out of the context. And what is the problem with the RAG systems, and especially while dealing with the unnecessary documents and broken queries and contradictory versions? Well, this makes hallucination not just a problem, but a liability itself. And that's where our problem statement came into picture. That is a self-correcting RAG pipeline, reducing hallucination and working even over messy PDFs. I have opted under the role of AI engineer, and this is my solution. Before that, why this problem statement? One Unbox is the company that is nothing but an operating system which believes that AI agents and humans work together to power the customer and meet their requirements and satisfy them. Thus making this problem statement a miniature version of the exact reliability problem one inbox has to solve every day on every message, on every call, and every email. So to overcome this, before to overcome this, I studied three research papers and I came up with a solution. My solution includes a 5-tier approach, and these 5 tiers are ingest, retrieval, orchestration and critic, generation and verification, and output and evaluation. So let us get into the live demo first before understanding how system works clearly. So you can see the Veritas RAG interface over here, and it has overall 4 execution triggers, that is factual query, contradiction trigger, ambiguity trigger, out of bound triggers. These 4 triggers have 15 questions in them. Actually, the ambiguity and the out of bounds are in one category itself, divided into the ratio of 3 to 2. And as you check, the pipeline trace shows exactly the pipeline here. So now we have executed the factual query. As you can see, factual query clearly showed for the question detailed answer, the correct answer. Before delivering into the answer, it retrieved and it over the re-ranking layers, and you can see that exactly what it had done in what it had retrieved from the ChromaDB database. And after this, the critic layer also gave a verdict that the context provided was correct and it was already present in the one inbox, and we were able to give the right answer. So, how does this database come into the picture? This database came by extracting. Uh, extracting by the guides provided by the resources by the organizer. So next is the contradiction trigger. While it is initializing, let me tell you what factual query is and then move to contradiction trigger. So factual queries are something where questions are standardized, where you know it and it is completely present and true. Like what is RAG, what is this? Now before that, here we also have the GitHub repository, and we are looking into the file structure of the GitHub repository. This is just for the GitHub repository. For the whole system, it is something else. We can see that later. And you can see this is the live what we have. However, in this you cannot put your own question. You have to try it from these 4 triggers itself because of the challenges that I faced, which I'll be explaining in the next slides. Because of that, I could not trace this. Now coming back to the factual queries, now we understood what factual queries are. So it has five questions in them. Contradiction trigger is something that is not sure. So you can see the routing is low confidence because you don't know where it came from. The verifier is flagged and the confidence is low. This also toggles between red and green color as per the output. And it clearly gave that I don't have verified information. Why? Because the one inbox guide showed one guide showed that it has only 6 tools, it supports only 6 tools, while the other show that it supports almost around 8 tools. So that's why it could not. Now, ambiguity triggers are something like it is not fully given. So if I tell how many types of agentic AI are there, while one inbox purely focuses on voice, if I just give that, it won't give me the output. It instead asks for the clear information. And out of bound triggers are something like who am I? Like it doesn't know the context at all. What is this? This is nothing related to what the projects are being done. So who am I? It will just clearly ask what are your intentions or what is it exactly, and you will get the output here soon. Like you can see, it did search for relevant or similar sort of things, but as it could not find, it clearly marked it and asked if you could please clarify the question. So now, here is a short video I have for you. It is very
When
interesting.
enterprise artificial intelligence fails, it usually happens quietly. We force standard retrieval-augmented generation models to process unstructured, contradictory, or messy data, and the systems break under the cognitive load, outputting fabricated information. This diagram illustrates why. In a standard linear pipeline, a user query flows straight to an LLM for generation. The system operates on an automatic trigger. If the retrieval step pulls incomplete or ambiguous context, the LLM is still strictly commanded to fulfill the prompt. Lacking the necessary facts, it relies on its training weights to guess, generating a hallucination to bridge the gap. Fixing this requires a structural correction. We have to treat text generation as a conditional privilege, not an automated default. Instead of a linear pipe, we insert a state-managed orchestration layer. The system must evaluate its own context before it is allowed to speak. Our objective is strict. Build a pipeline that issues a requery, asks the user for clarification, or returns a low confidence flag, rather than ever attempting to pass off a plausible lie. This schematic outlines the complete architecture to achieve that. It is is a 5-tier self-correcting RAG pipeline, moving sequentially through ingestion, retrieval, orchestration, verification, and evaluation. Deploying high-trust AI means we abandon probabilistic coping. We replace it with deterministic, agentic routing that tightly controls when a model is allowed to generate an answer. The first obstacle is the source material. Real-world enterprise knowledge bases aren't perfectly formatted text files. They are dense PDFs, low-resolution screenshots, and scanned images. At the far left, the ingestion tier tackles this. We extract raw text using PyMuPDF and Tesseract OCR for scanned documents. As text is chunked, we apply strict metadata tagging, recording source, page number, confidence score, and document tier. Capturing this metadata at ingestion costs zero compute overhead, and it gives downstream logic the variables needed to resolve factual contradictions based on document authority. From there, the data enters the retrieval tier. A hybrid dense and sparse search inside a ChromaDB vector database queries the corpus to find the top 20 candidate chunks. Our cross-encoder reranker rescores the 20 initial candidates, aggressively filtering them to a strict top 6. By bounding this computationally expensive process to just 20 candidates, we maintain exceptional precision without scaling compute costs against the entire database. This tightly bounded retrieval tier acts as a quarantine zone. It guarantees that only the most relevant high-quality context ever reaches the orchestration logic. Once the context is isolated, we hand control to the brain of the pipeline, the LangGraph managed agentic orchestrator. In the center sits the critic layer, mandated to rigorously interrogate context before generating any answer. It performs a triad of checks, evaluating if text is sufficient, scanning for internal contradictions, and assessing if the initial query is clear. Executing these checks as 3 separate prompts would triple latency. Instead, we batch them into a single API call with temperature lock. Path 1 generates answers from sufficient context. Path 2 rewrites malformed queries. Path 1 retry. Paths 3 and 4 skip generation entirely, outputting low confidence flags for weak context or prompting the user for clarification. Path 5 is an audit mechanism. If retrieved documents contain a direct, unresolved contradiction, the router surfaces those conflicting sources directly to the user. This deterministic matrix forces a graceful failure based on the evidence. A system that knows exactly when to stop processing is a reliable autonomous agent. But the architecture is not yet complete. Even with a strict critic passing perfect context, generative models can suffer from drift during text assembly, inserting words never found in the source documents. We have to deploy a final safety net, dual model verification. Looking at the terminal nodes of this pipeline, the drafted text moves from the generation stage immediately into the post-generation verification tier. We do not use a standard LLM here, but a specialized non-generative token classification encoder model to verify the output. Encoders strictly classify inputs rather than generating text, providing a mathematically distinct cross-check for factual grounding. Note a minor documentation artifact in this exploited diagram. The output port labels are visually swapped, but the underlying system logic remains rigid. If the encoder detects text unsupported by the citations, it triggers the top port, forcing the generator to attempt a rewrite, capped at 1 regeneration to maintain bounded latency. Once the text passes verification and is confirmed strictly factual, the right port releases the final answer. You cannot rely on a single generative model to grade its own homework. Fact-checking requires heterogeneous technology stacks. This animation traces the final data flow through our deterministic 5-tier RAG architecture, passing successfully from primary extraction through verification. You will notice the deliberate exclusion of common industry techniques, specifically semantic query caching. Semantic caching optimizes for response speed. Our engineering mandate is the reduction of hallucinations on variable messy data. Returning a false answer faster solves nothing. The finalized output JSON schema, which includes the answer, its strict citations, and a confidence label, is finally routed to the output and evaluation tier. This final node represents our evaluation harness. We route the data through a 15-question RAG test sequence. This provides a quantifiable baseline, allowing us to empirically measure retrieval precision and the exact drop in hallucination rates compared to a standard pipeline. Trust in a system is built by ensuring it knows exactly what to do when the correct context is missing. Production-ready infrastructure is not built by hoping a model behaves correctly. It is achieved by architecting rigorous systems where delivering a false answer is structurally impossible. When enterprise
Well, now that we have understood, let's get to know what other things we have implemented as well. After round one, we had received an feedback, and based on that feedback, I was able to implement these as well to make it production eligible product. I implemented GDPR compliance, EEOC compliance, LM observability and tracing, that is using OpenTelemetry, this prompt engineering as well. Now, this is our file structure, and as you had seen in the video, how the file tier worked using PyMuPDF for extraction, OCR detection, and all, and this was the file structure. Now, the major problem is challenges. Well, building this all wasn't easy. It did come with challenges. My first challenge I faced was under the deployment. So this is a huge AI model. First of all, I tried it at Hugging Face, but Hugging Face didn't provide us free tier. That is for and for Docker as well, we have to pay. That was the updated policy this year. So I thought render is only file, but render gave the OOM error. That is, the renderer's free tier gives only 512 MB of RAM only. So the three models of embedding, re-rankers, verifier were just crashing out each time. So to overcome this, I introduced sequential model loading, but even this wasn't enough. It still gave the same errors itself. So lastly, I decided to use a lightweight model instead. So the lightweight model, basically, you use API instead of your own PyTorch whole code. So that's why we have few uh, problems when you look at the deployed link. You cannot use other questions. You can just use from the 4 triggers itself. So I please refer you to the go to GitHub repo and install it on your local host. Now, since I had used the sequential model loading here, I got another challenge of time and latency, where almost around 1 second of latency was found in it. Now, to overcome this, we can use microservices and better hardware GPUs when you have proper gears in your hand and proper money in your hand. Well, that was it. That was my solution. They say that the greatest enemy of knowledge is not ignorance, it is the collision of knowledge or illusion of the knowledge. And Veritas RAG never gives you that. Thank you. That was my solution. Thank you again.